sorry I'm not here today. You're stuck with the ghost of me. You talked about scales. You use scales. You're pretty good at scales. Longitude and latitude. We've talked a little bit about them. Some of you might be pretty good at them. Just want to make sure we're all on the same page. So these are our goals, differences between them, finding things on a map. In a moment, you're going to be given the paper that's going to tell you to look at pages 111 and 112. It's in your tablet under the map section, or it's in the book. There are 16 questions on the front. You're either to answer them latitude or longitude. That's your formative, that's your practice, you would call it. On Friday, we'll come back. It'll look very, very similar. And it'll be the summative. Okay, the teacher will pass out that paper now. Please take the next 8-9 minutes to work on that. That's finished. This is for you. You need to know the difference between the two. I think the best thing, if you were given a blank sheet of paper and ask you to tell me the difference between longitude and latitude, we start making those two lines. And once you have those two lines correct, most everything else should fall into place. The hint I gave the other day came from Mrs. Farnham many years ago. We said latitudes have attitudes. Remember that one? And by saying that, these lines never touch. If you got an attitude, don't touch me, stay away from me. Get away from me, I got an attitude. That's her way of remembering it. But longitudes are party dudes, according to Mrs. Farnham. And of course, when you have a party, you don't party alone. That's not a party. You get together. You find some friends and meet at the polls. Be careful there. All right, if that works, whatever. The other way I've been heard students say was think of a ladder. When they think of a ladder, it maybe sounds like latitude, and they think of climbing up and down the rungs of their ladder. Perhaps that helps. Whatever it takes, you got to know the difference. Once you've done that, it kind of makes sense. The equator is a line like that. Tropics of Cancer and Capricorn are these dashed lines above and below the equator. Look like that. Prime meridian. Oh, it goes up and down, doesn't it? International dateline. You may not be real familiar with it. It's on the other side of the globe. It goes up and down also. You need to read well what's in there. These longitude lines all converge at the poles, whereas latitude lines are parallel, hence they never meet. All right, these two people get mixed up. Draw you some latitude lines. Now start jumping up and down, touching the lines. Oh, I'm going south. I'm going north. I'm going south. As you change latitude lines, you're measuring how far north or south you are. Drawing south. So longitude lines. Start jumping back and forth. I'm going east. I'm going west. I'm going east. I'm going west. So longitude lines measure how far east and west you are. Very often turned around. Now, when you look at them, some people use these phrases. Well, those lines run from the top to the bottom. Those latitude lines go side to side, and they never touch, so they are parallel. Since they are parallel, they'll always be the same distance apart. And since we draw these lines up and down, we quite often put the numbers at the top and the bottom, the longitude lines, whereas latitude lines more often are on the sides. Check your work. Keep that side of the paper, right? That's your help for Friday's real quiz. It's going to look a lot like that. Take your notes out. Got more than a few things you need to write down. Thank you. Now, take your notes down. Who came up with this whole idea? Well, Ptolemy is given credit for it. We said before he really was an astronomer. He really knew there was one object in his little part of the world that was always a constant. That was the North Star, Polaris. So he said, well, let's turn all our maps the same way. And let's put north at the top. When you put north at the top, south at the bottom, east becomes the right-hand side, west becomes the left. And on a map, for some reason, that's called the direction rose. The direction rose. You learned the other day that north has two meanings now. Geographic north is where the axis, the imaginary line, the imaginary poles we spin around. And that's where everyone thinks the poles are. But when you get your compass out, you find your way out of the woods, it's pointing to a spot you learned the other day that's in northern Canada. It's a couple hundred miles off. It moves. The magnetic pole today is not where it was 10 years ago or 100 years ago, or it's not where it will be 100 years from now. But it's close enough to the geographic pole that it finds your way out of the woods. We've already talked about latitude lines, go side to side. They go clear around the world. The equator would be the largest circle. That's why we start there. We have to begin someplace. So let's start the fattest part. Let's start equal distance from the poles. And that's how the equator got its name, the whole concept. And so as you go above the equator, your north latitudes. And as you're below the equator, you're in south latitudes. Hence the northern and southern hemispheres. Hence they measure how far south and how far north you are. Down here. When do you run out of north? You run out of north when you hit the pole. And since the Earth is somewhat of a circle, you start at the equator. This is a side shot. You go further north and further north and further north and further north. You run out of north when you're a fourth of the way around. So if you take 360 total degrees divided by 4, 1/4, that's how you get the fact that the poles are 90 degrees north or 90 degrees south, excuse me. So if you're reading someone's imaginary longitude and latitude, and their latitude is 102, they made a mistake. 90 is the biggest it could always be. On the other hand, longitudes, they're also called meridians. Meridians are half circles. They needed a place to begin. Primary school, beginning. He said, where should we begin? There is no magic spot like the equator between the poles. So you could have put this up and down line any place. If I'd been making the map, I'd have made it right by through Nicholsaver. Right down 127 by my house. I'd have made that the prime meridian. Well, it wasn't my choice. At this time, England ruled the world, practically. The sun never set on the British Empire. They had the 13 colonies, you may have heard of them. They had colonies in South America. They had colonies in the Pacific Ocean. They had colonies, India was a giant, massive colony. For that, they had colonies in Africa. They had colonies around the world. So, the king was map maker, cartographer, was laying these lines down, and different people were using different beginning spots. And he just said, well, shoot, the Royal Observatory, that was strange. The Royal Observatory is in a little town called Greenwich, which is right outside of London. So if you find England on a map, you need to be able to find England on a map. Find Europe, find England is that island thing sitting above France. That's the prime meridian. That's just where they chose to begin it. Could have been anywhere. King of England had enough power to make this thing happen. All right. Once they decided the prime meridian, they then said, okay, there we go again. We'll make lines beside it. They're not parallel because they're going to the poles. And as I go this way, we're headed east. As I go this way, we're headed west from the prime meridian. Now, east meets west on the other side of the earth then. If you go halfway around 360, you're at 180. And on the opposite side of the prime meridian is what we call the international date line. It gets its name because that's where today started. If today is September 27th, the first people to see September 27th were people in New Zealand, people in Siberia. And as the Earth rotated to the east, then people in Australia got to see September 27th. People in China, people in India got to see it. The world kept turning. Africa finally got to see morning. We were still in nighttime. We were still sleeping. Europe got to see morning. And then, I don't know, what time is it here? For you guys, it's after 11. So 11 hours ago, today started with Eastern Daylight Savings Time in Ohio. Finally, we got to the day side. Some of the world's almost ready for tomorrow. That's strange to say. So out in the Pacific Ocean is this invisible line that as the sun passes through there, the day begins. Ohio, United States, California, Hawaii, we're at the end of the day. New Zealand, Japan, they're at the beginning of the day. Now we get to the specific stuff. A degree of latitude is about 70 miles apart. You take a peek at Ohio, you can see down here's 39 north, 40 north, and that's about us. We're about in here. We're almost 40 degrees north of the equator. Get up here, Sandusky area, etc. They're around 41. They're farther north than we are. So from one line to the next line, it's about 70 miles apart. That's not very precise. That's kind of far apart. So if Jared is out hiking in the wilds, falls and snaps his ankle, there's no one around, he gets his cell phone out, he calls for help, and he calls us here at National Trail. We say, hey Jared, how you doing? He says, not very good, my ankle's broke, I need a little help. We said, we're on our way. How will we find you? He said, oh, GPS, I got GPS. So if we find out his coordinates are, let's say, 40 north, 84 west, we know Jared is somewhere in that area. Good luck, Jared. We could be 70 miles away from you. That's as good as we got. So we need to break degrees down into more specific. Write this down. 1 degree is divided into 60 smaller pieces. We call these smaller pieces minutes. Not to be confused with minutes of time. These are minutes of distance. These are minutes of distance. And since you take 70 and 60, take 70 divided by, 60, you get 1.1508. You get that number right there. A minute of latitude is a little over 1 regular mile. It's 1.1508 miles. Sometimes referred to as a nautical or ocean mile. So down here, if you go from 83 west to 84 west and chop it into 60 smaller pieces, each little tiny line is called a minute, and each little tiny line is 1.1508 miles apart. So, back to Jared. Hope you're doing okay out there. If he says, oh, my cell phone's GPA is 40 degrees, 12 minutes north, and it is 84 degrees, 15 minutes west, instead of being somewhere within that 70-mile area, we got you within a mile of you about. Good chance we'll find you. Unless the wolves are getting close. We're more precise. We can find you in a smaller area. Now, sidebar. You're out in your ocean boat in the ocean. Now on land, you have wheels that go round and around on the bus. As the wheels go round and around, they come in contact with the ground. As they go around, your car keeps track of how far you go by the circumference of your tires. That doesn't work in the ocean. The wheels don't go round and round. They don't stick to the water. Instead, they had to use their compasses and the sun and the moon and the stars to come up with degrees of latitude and degrees of longitude. When they traveled 1 minute of latitude, that was called 1 nautical mile. A nautical mile is a little bit bigger than a regular land mile. Statute miles is the fancy word for land miles. And if your battleship is going one of these kind of miles in 1 hour, your battleship's traveling at 1 knot. Big boats travel in knots, not miles per hour. If you're going 25 knots, you're going 1.1508 times 25, and that would be, according to my calculator, 28.77 miles per hour. 25 knots is almost 29 miles per hour. So, if Amanda's in her battleship, going 10 knots, and alongside over is Dakota in his truck going 10 miles per hour, who's going faster? Well, of course Amanda is, isn't she? Because her knots, each of her longer miles, is longer, a little bit, than Dakota's miles. Well, back to Jared. We're getting closer. Jared, we're still a mile, 1.1508 miles away from you. We're not quite sure where you're at. It's getting dark and we want to go home. Oh, if your GPS is good enough, there we go again, we can take a minute and divide it into 60 seconds. And it might be 40 degrees north, 40 degrees, 12 minutes, 6 seconds north. We're going to add that. 84 degrees, 15 minutes, 12 seconds west. If we can be that precise, we're within 101 feet of you. That's about the length of the hallway. If we're that close to you, Jared, we'll probably find you. You're driving down the road. You got your GPS on, your North Star, your TomTom, whatever you have. How does it know exactly where you are? Right here. It's measuring you down to better than this. Better than 100 feet. It pinpoints you down to maybe within a foot or two. Now, looking at my audience, I don't know if I have too many agriculturists in here, but if you're a big-time farmer today, you farm by GPS. You have a satellite dish up on top, a receiver up on top of your combine. You have a satellite up on top of your tractor, and as you plant in the spring, it records where you are. You turn the end row, and then you let go of the steering wheel, and the satellite in space steers your tractor straighter than you can steer it. You get to the other end, you got to wake up, grab the steering wheel, turn around, and then the GPS drives it again. And I believe they get them within 4 inches. That's pretty amazing. You got a field, and it has good soil on one side, and this red clay hill, it doesn't have very good soil in it, there's some sandy soil. You don't want to plant everything the same depth. You don't want to plant everything the same population. You don't want to fertilize all that field the same. You want to be able to precision plant, it's called. So when Harvest Land comes in with their great big sprayer, it's got a little satellite antenna on it too. And it sprays, it applies fertilize based on what part of your field needs fertilized the most. It increases and decreases the rates on the electronically, digitally controlled spray nozzles. As you plant it, with your big old $250,000 planter, it controls what part of the field gets more, what part of the field gets less seeds planted. So this is not just a bunch of stuff that you'll forget, but it might come in use sometime. Once again, I remind you, on Friday, last Friday, you're going to have the summative quiz. Take that same sheet of paper out, answer the question 20 at the bottom if you would. I'd give you the answer to that one. Turn it over. At the top, it talks about the prime meridian. That's not a question at the top, it's just a statement. It then is going to have you look in the book, and you can use, you and the person next to you do this together. You've done part of this. You've done A, B, C, and D, I believe, on page 124. But this asks you to look up 4 more cities, if you would please, now that you know a little bit better. And then E, F, G, and H on procedure 2 is the flip side. You need to find the cities, use the map. At the bottom is a weird thing called the antipode. If you were to dig a hole and actually hit the center of the earth, you did not pop out in China. If you popped out in China, you dug crooked. It says change the north or south, but leave the number the same. Change the east or west, but leave the number the same. So you're really just flipping the direction, but leaving the numbers the same. I need to grade the back, but ironically you need the front. So I'm going to have you keep this. I expect it to all be done. I expect whoever's subbing to walk around and check that you're doing the back. This should all be ready to turn into me Friday when I come back. You need the front for your quiz. Thank you. Get to work.